The voltage rating of a disconnect switch indicates the maximum voltage that the switch can safely handle between its terminals without experiencing arcing or failure. Exceeding the voltage rating can lead to insulation breakdown and potentially dangerous electrical arcing. The amperage rating of a disconnect switch specifies the maximum continuous current that the switch can carry without overheating or sustaining damage. If the current exceeds the amperage rating, the switch components can overheat, leading to premature failure or even a fire hazard. The horsepower rating of a disconnect switch is related to its amperage rating, but it specifically addresses the demands of inductive loads such as motors and transformers. Inductive loads introduce reactive power into the circuit, causing a phase shift between voltage and current. This phase shift results in a higher apparent current draw than the actual current. The disconnect switch needs a horsepower rating to handle this increased current demand without overheating. The disconnect switches have different ratings because they are used in various applications with varying electrical characteristics. The voltage rating is used to determine the safety of the switch in different voltage environments. The amperage rating ensures that the switch can handle the current demand of the circuit without overloading. The horsepower rating accounts for the increased current draw of inductive loads, preventing the switch from overheating or failing. Disconnect switches use 3 different ratings to be properly selected for specific applications, ensuring their safe and reliable operation. Here's a more in-depth look at why each rating is important. The voltage rating is the maximum voltage that can be safely applied across the terminals of the switch. Using a switch with a voltage rating lower than the system voltage can result in arcing, insulation breakdown, and catastrophic failure. Arcing can damage the switch and pose a significant safety hazard. The amperage rating is the maximum continuous current that the switch can safely carry. Exceeding the amperage rating will cause the switch to overheat. This can lead to premature failure, component damage, and potentially a fire. The horsepower rating indicates the switch's ability to handle the inrush current and continuous load of motors and other inductive loads. Motors draw significantly more current when starting than during normal operation. Inductive loads introduce reactive power, leading to a higher apparent current draw. A switch with an adequate horsepower rating is designed to withstand these demands without overheating or failing. Choosing the correct disconnect switch involves matching the voltage, amperage, and horsepower ratings to the specific application requirements. Here are some factors to consider. Firstly, voltage requirements. The switch's voltage rating must be equal to or greater than the system voltage. Secondly, current requirements. The switch's amperage rating must be equal to or greater than the continuous current of the circuit. Thirdly, load type. For motor applications, the switch's horsepower rating must be equal to or greater than the motor's horsepower. Also consider the ambient temperature and enclosure type, as these factors can affect the switch's current carrying capacity. To elaborate further, let's look at the voltage rating. The voltage rating ensures the switch can interrupt the circuit safely without arcing, which could lead to equipment damage or personal injury. Standard voltage ratings for disconnect switches include 240 volts, 480 volts, and 600 volts. Although other voltage ratings are available. You must select a switch with a voltage rating that meets or exceeds the system voltage to ensure safe operation. Next, the amperage rating. The amperage rating is critical for preventing overheating and potential fire hazards. This rating specifies the maximum continuous current the switch can handle without exceeding its temperature limits. To determine the appropriate amperage rating, calculate the full load current of the circuit and select a switch with an amperage rating that is at least 125% of the calculated value, especially for continuous loads as per the National Electrical Code Section 210.19. Lastly, the horsepower rating. The horsepower rating is particularly important for applications involving motors and other inductive loads. Motors draw a high inrush current during startup, typically several times their full load current. The switch must be able to withstand this inrush current without damage. Additionally, inductive loads cause a phase shift between voltage and current, increasing the apparent power demand. The horsepower rating accounts for these factors, ensuring the switch can handle the motor's starting and running requirements. When selecting a disconnect switch for a motor, consider the motor's horsepower, voltage, and full load amperage. Use the NEC tables to determine the appropriate switch size based on these parameters. The NEC provides detailed guidelines for motor circuit protection and control, including disconnect switch sizing. In summary, the voltage rating ensures safe interruption of the circuit, the amperage rating prevents overheating, and the horsepower rating accommodates the demands of inductive loads. By carefully considering these three ratings, you can select the appropriate disconnect switch for your application, ensuring safe, reliable, and compliant operation. Properly selected disconnect switches are fundamental to electrical safety and equipment protection. Selecting the correct disconnect switch involves a careful consideration of voltage, amperage, and horsepower ratings. Mismatching these ratings can lead to unsafe conditions, equipment damage, and potential code violations. Firstly, regarding voltage, always verify that the disconnect switch's voltage rating is equal to or greater than the system voltage. Using a switch with an inadequate voltage rating can result in arcing, insulation breakdown, and potentially catastrophic failure. Secondly, for amperage, the disconnect switch must be able to handle the continuous current of the circuit. Select a switch with an amperage rating that is at least 125% of the continuous load current to account for safety margins and potential overloads. Thirdly, concerning horsepower, when used with motors or other inductive loads, the disconnect switch's horsepower rating must be sufficient to handle the motor's starting and running characteristics. This includes the inrush current during startup and the reactive power associated with inductive loads. Let's look at how to determine the appropriate disconnect switch size for motor applications by following these steps. 1. Determine the motor's full load amperage from the motor nameplate. 2. Apply the appropriate NEC table, such as table 430.250, to find the full load current based on the motor's horsepower and voltage rating. 3. Select a disconnect switch with an amperage rating that is at least 115% to 125% of the motor's full load current, as required by the NEC. 4. Verify that the disconnect switch's horsepower rating is equal to or greater than the motor's horsepower. 5. Consider any additional loads or equipment connected to the circuit when selecting the disconnect switch size. The NEC provides specific guidelines for sizing disconnect switches for various applications, including motors, transformers, and general-purpose circuits. Always consult the NEC to ensure compliance and safe operation.